Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic variation. In the previous video, we solved a question on partial variation. In this video, we are going to solve another question. The question for this video is: the pressure of a liquid in a tube is partly constant and partly varies as the square root of the cross-sectional area. When the pressure is at 990 millimeters, the cross-sectional area is 2.25 millimeters. And when the pressure is at 842 millimeters, the cross-sectional area is 6.25 millimeters. Find the cross-sectional area when the pressure is at 770 millimeters. Correct your answer to 2 decimal places. So this is an example of a partial variation. The pressure depends on two things. It depends on a constant and on the square root of the cross-sectional area, or on the cross-sectional area. We are being told that it's partly constant, the pressure is partly constant and varies partly as the square root of the cross-sectional area. To solve this question, we need to define the variables that we'll be using in our solution. So we are going to let P represent the pressure of the liquid and we will let A represent the cross-sectional area. The question told us that the pressure in the tube is partly constant. So we are going to represent that constant with C. So C is equal to the constant. Now from the question, we know that the pressure of the liquid, which we have represented by P, is partly constant, and we are representing that constant by C, and partly varies as the square root of the cross-sectional area, which we have represented by A. So we can see from here that the pressure is in two parts. The first part is a constant, so the first part is the constant, and we have represented that constant by C. The second part is a direct variation because you are being told that the pressure, which is P, varies directly as the square root of the cross-sectional area. That means that P varies directly as the square root of the cross-sectional area. So P is directly proportional to the square root of the cross-sectional area, which is A. If we introduce the constant of proportionality, then P is equal to K root A, where K is the constant of proportionality. So P is in two parts. The first part is C and the second part is K root A. That means that P is equal to the first part, which is C, plus the second part, which is K root A, where K is the constant of proportionality. Now we need to find the value of C and K in order to get an expression connecting P and A. We are being told that when the pressure is at 990 millimeters, the cross-sectional area is 2.25 millimeters. So we can say that when P is 990, the cross-sectional area, which is A, is 2.25. We know that P is equal to C plus K root A. So we can replace P with 990 and A with 2.25. When we do that, we are going to have 990 is equal to C plus K root 2.25. Square root of 2.25 will give us 1.5. So this will give us 6C plus 1.5K is equal to 990. This is equation 1. The question also told us that the pressure is 842 millimeters when the cross-sectional area is 6.25 millimeters. So when P is 842, A is 6.25. So we can substitute these values into this equation. When we do that, we will have 842 is equal to C plus K root 6.25. So square root of 6.25 will give us 2.5. This is going to give us C plus 2.5K is equal to 842. This is equation 2. So we have two equations with two variables. We are going to solve these two equations simultaneously for the value of c and k. We will solve the simultaneous equation in the next video. So see you in the next video, and let's continue solving this question.